Assalamualaikum and I wish you a good day. We are from BMMV 1 2 and Group 4. In this video, we would like to present on our assignment, on our static assignment. First of all, I would like to introduce myself and my fellow members. I'm Muhammad Sobe bin Muhammad Sadiq.
I'm Muhammad Hasif bin Muhammad Tahir.
I'm Muhammad Hakimi bin Nazri.
I'm Nur Azmina binti Muhammad Razi.
I Muhammad Nazri bin Muhammad Dim.
Okay, before we start this assignment, we are directed to find three different objects in our daily life that we can extract the free body diagram and find the forces acting on those objects. Then we are supposed to choose one of the object that has been chosen earlier. And we chose this phone stand. And we chose this phone stand with the guidance of our instructor. We chose this phone stand because it is easier to make assumption and it has more variables that can easily manipulate. Since this phone stand is adjustable in terms of either the angle between the base and the stand or the length of the stand. And we chose and and we chose to manipulate the length of the stand. Therefore, these are the assumptions that we made while we extracting the free body diagram. First of all, these are the manipulating value that we assume. We are using the length of stand is 0.1 meter, 0.1 0.10 meter and 0.15 meter. Next, we also assume the angle between the base and the stand is fixed, which is 60 degree. Next, we assume the mass of the load is 0.2 kg because the average mass of a phone point B is a pin and it has reaction force at x-axis and y-axis. Next, I would like to pass the presentation to my fellow member Hasif.
Okay, for my part, I would like to explain about the free body diagram. At the point A, we can see a load at this point. Its value coming from multiplying the mass and the gravitational force. And the value of weight is 1.962 Newton since the average of mass that we take from the load is 0.2 kilogram. At the point B, we assuming point B is a pin and has reaction force. We fix the value of angle, the angle base and the stand is 60 degrees. There will be two axes, x axis and y axis. For the length of stand, we manipulate the length of stands. We it's to find the reaction force, which is we assume the length of stand is 0.05 meter, 0.10 meter, and 0.15 meter. Okay, that's all for explanation about the free body diagram. And I would like to pass to my fellow friends, Hakimi.
Okay. Assalamualaikum warahmatullahi wabarakatuh. For my part, I will explain about calculations. Calculation on our assumption when the length of stand is 0.05 meter. First, we start from x-axis. We know our net force on the f-axis is equal to 0. So to find the reaction force NB at the point B on the x-axis, we just have to minus with FBA. Yeah, to find the force FBA, we just need to times the length of stand, which is 0.05, times with the angle cos 60 degrees, and then we bring to the other side, and we have the reaction force at the point B. X-axis is actually just 0.025 Newton. Next, on the y-axis, we also know the net force on the y-axis is equal to 0. But for this time, we have third force, which is weights, negative weights, plus with FBA, and plus with the reaction force on point B, y-axis. So to find the force FBA, we just need use the length of stance 0.05 times with the angle sin 60 degrees, and the weights, we already know the mass of load 0.2 kilos. We just have to time with 9.81, and we got the uh, value is negative 1.962. Plus we have to plus both of the force, and we got negative 1.9187. Bring to the other side, and we have the value for the reaction force of B on the y-axis is 1.9187 Newton. Thank you.
Okay, for my part, I will explain about assumption 0.10 meter. And this assumption, we just change length of stand. So total force on x-axis equal to 0. Reaction force at point B on x-axis minus with FBA, which is 0.10 multiplied with cos 60 degree equal to 0. Then we got negative 0.05 equal to 0. So for reaction for FB on x-axis is 0.05 Newton. So next, total force on y-axis, negative weight of load plus FBA, which is 0.10 multiplied with since 60 degree because other side of angle, plus reaction force on y-axis equal to 0. Then we got the weight negative 1.6962 because of mass multiplied with gravity, and FBA we got 0.0866 plus reaction force FB on y-axis equal to 0. We sum the weight with the FBA, we got negative 1.8754 plus with reaction force on y-axis equal to 0. So reaction force FB on y-axis, we got 1.8754 Newton. I will pass for my next member.
For my part, I would like to explain about assumption 0.15 meter. Reaction force in x-axis equal to 0. Reaction force B in x-axis minus length of stand, which is 0.15 multiply angle in between, which is cos 60 degree equal to 0. After the calculation, reaction force B in x-axis minus 0.075 equal to 0. And then minus 0.75 bring to the other side, which is reaction force B in x-axis equal to 0.075 Newton. Furthermore, reaction force in y-axis equal to 0, and then minus weight plus leg of stand, which is 0.15 multiply angle in between, which is sin 60 degree plus reaction force B in y-axis equal to 0. And then minus 1.962 plus 0.299 plus reaction force B in y-axis equal to 0. And then after the calculation, which is negative 1.8321 plus reaction force B in y-axis equal to 0. And then negative 1.8321 bring to the other side, which is reaction force B in y-axis equal to 1.8321 Newton. Thank you for giving us the opportunity for this presentation, static assignment on stand.